Hi everyone. Today we are going to talk about 1.1 function notation. So since this is belong to the Algebra 1 level, it will be very familiar to you. You learned this about 2 years ago, right? We are going to review Algebra 1 level about 3 weeks. It could be, I think, because it's online. So what is that? So we are going slower than before. It might be more than 3 weeks now. So 1.1 function notation. So we are going to learn how to evaluate the function values. Okay. Before we start the lesson, I want you to think about this do now. I'll give you 4 problems for do now. So can you determine if the relations are functions or not? And then can you explain why? 2 graphs, number 1, number 2. So can you think about it, if they are function or not? And then number 3 and 4, like this. These relations, are they function or not? Do you remember how to do this? Okay, can you do it? So please do it in your note. Or if you printed out the packet I gave you through online. So if you print it out, you can write on it, but please write down your name on every single page so that you know that's your, it proves that that's your own work. That's very important. Please write down your name on every single page you hand in later. So please, so either you can do it on the loose leaf or the paper you printed out. So now, so how do you think number 1? Is it a function or not? So what do you do to, to check this is a function or not? Yes, you do the vertical line test, right? If you draw the vertical line, if this vertical line intersect this curve just at most one time, right? Or if you don't touch anything, it's okay. Or just one time, anywhere. Then this is function, right? But it passed the vertical line test. But look at the number 2. You draw vertical line here. How many times does it touch? 1, 2. Then you don't need to look at other places. At least if you see anywhere it touches more than one time, 1, 2, here, 1, 2, 1, 2. Here you touch only one time or 0 time here, but it doesn't matter. This is not the function. So how about this? When you have a coordinate points, right? Then how do you determine this? So if you know how to do it, it's okay. You already by taking a look at this, you can determine the function. It's okay. If not, there's another ways you can plot these points on the coordinate plane. That's why I gave you the coordinate plane here. So number 3, is it this a function? Yes, right? Take a look. So if you plot this, all the points on the coordinate plane, -5, 0, -1, 5, 0, 0, 1, 5, 5, 0. So vertical line test, if you do it everywhere, you just touch one time or 0 time. So this is a function. So think about it in this case. We learned that X value is input value, right? Input. If there's any machine, and let's think about the bending machine. If there's a bending machine, and if you want to get Coke, you press the Coke button, right? So when you press the Coke button, that's the input value. Then what does it come down? Yeah, your coke must be, actual coke will be coming out of the machine. So that's the output. So when you press the coke button, what do you expect to get? Coke, not the orange juice, right? So whenever you press the same button, always you expect same output, right? That's a good vending machine. But if you press the Coke button, today that machine give you the Coke, but tomorrow it give you the ginger ale. Is it all right? No, it's not right. So that we call not a function because the machine doesn't function well. So same input always give you same output. But sometimes you can give the different input, but different buttons, make them all Coke buttons. Can you do that? Yes, right? So different input can give you all Coke, same output. That's okay. That's okay. The good function. But whenever you give the same input, you should always get same output. So -5, there's only one -5. It's okay. Only -1, so 0, 1, 5. So input values are not repeating, right? So that's a function. But if you look at the number 4, what happened? 1, 1, 2, 3, 2, 5. What happened? This one, same input value, give you two different output. So number 4 is not a function. If you look at the graph, look at this. Yes, 1, 1, 2, 3, 2, 5. Vertical line test fails, right? That's the do now. So let's go to our lesson today. Function, you know, this is the definition, a relation between a set of inputs and set of input is x values. Mostly we know x values, and set of outputs with the property that each input is related to exactly one output. Each input must be related to only one output. Now, no more than one output, right? But different input can go to the same output is okay. But the same input go to the only one output. That should be the function. So it looks like this is the machine. If you put the x value here, this machine work inside and calculate something and give you output. And we call it f of x. So f of x is the function. So mostly we use in the algebra 1, we wrote down y instead of f of x. But instead of y, we use f of x or g of x, h of x, it doesn't matter. But in the parentheses, x means x is the input value. The f of x is the y output value. So if you see the example, it will be much clearer, so don't worry. So let's see the example. Oh, before I show you the examples, there are many functions. 6 different functions, right? Linear function, quadratic function. Up to here, we learned quadratic function is y equal to x squared, those things, plus 2x minus 4. But now, in Algebra 2, we are going to learn also polynomials, exponential function, logarithmic function, and trigonometry function. So this one I will skip. So when you do the evaluation, there one thing we should be careful is when the input values are negative or fraction. You know, input values, if x, input values are negative or fraction, what should you do? Put them in the parentheses. This is very important, please. You should remember, don't forget, if x values, input values are negative or fraction, you should what? Put them in the parentheses and substitute it into the function and you will get the right answer. If not, most of the time you will get the wrong answer. Sometimes they give you the right answer, sometimes, but just a few times. So you will see. Let's see with the examples how to evaluate. So I give you the two functions, f of x, g of x, doesn't matter. They are all y. So y is equal to this, y equal to this. The two different functions are here. Oh, you never saw this kind of functions in algebra 1, right? So now we see this. Oh, a fraction. Your function is in the form of fractions. We call it rational function. But now we are going to learn more in detail later. So let's think about what is f of negative 2. F of negative 2 means instead of f of x, instead of x, we have what? Negative 2. So we find y value when x is negative 2. That's the meaning of f of negative 2. So what do we do? We plug, substitute x equal to negative 2 to this function, right? But what should you remember? I told you to be careful. What? Yes, you should put the negative number in the parentheses. So how do you do it? Like this. Use the parentheses. Negative 2 to the third power within parentheses. Plus 2 times parentheses negative 2 minus 4. If you put exactly like this in the calculator, you will get the right answer. The calculator will give you the right answer. But without parentheses, if you put it into the calculator, this case, you will get the right answer. Only this case. But most of the time, you will get the wrong answer. Please remember, use the, so negative 2 to the third power is negative 8. 2 times negative 2 is negative 4. Minus 4, answer is negative 16. Is it clear? Again, now, g over half. Oh, this x value is also a fraction. Then what should we do? Yes, we should use parentheses again. Then you half here, right? Then it will be like this. Half plus half, 3 times half minus half. If you simplify, let's do it step by step. How about the numerator? Half plus half is? Yes, 1, right? 2 over 2, right? 1 plus, if you have a common denominator same, then you can add or subtract the numerators. So 1 plus 1 is 2. So 2 over 2 is 1. So numerator is 1. So how about denominator? 3 times half is, you multiply 3 to the numerator, okay? Not the denominator. So 3 times 1 is 3 over 2. And then subtract half. So still, this one, they have a common denominator. So you subtract the 3 minus 1 is 2. So 2 over the common denominator 2 is 1. Oh, denominator is also 1. So 1 over 1, which is 1. So g over half is equal to 1. Is everything clear to you now? All right. Then I'll give you the error analysis. Oh, before I give you the error analysis, we have a now graph. This graph is f of x. The function is not given, but this is f of x now, right? Then can you find out what is f of negative 2, f of negative 1 like this? Sorry. So f of negative 2 means we are going to get y value when input x is negative 2, right? So what is y value when x is negative 2? Negative 2, here is a 0, 0 origin. -1, -2, y value is 1, 2, 3, 4, and more. About -4.5, right? So this is -4.5. Now, can you get it? Then can you tell me what's f of -1? F of -1. Is it 0? No, right? A little bit here. Oh, it's a positive 0.5. How about f of 0? X is 0 here. Y value is 1, 2, 3. Oh, f of 0 is equal to 3. Do you get it? How about f of 1? 1 is here. 1, 2, 3, 4. F of 1 is 4. How about f of 3? Here. 0. How about f of 5? 5 here. So 1, 2, 3, 4. So f of 5 is equal to -4. Right? So I think everybody know how to evaluate the function in the graph or in the actual function like this before. So now I want you to see this. I'll give you error analysis. Okay. So Sarah evaluated f of -3 from this function. 3x to the third power minus 2x squared minus 6. There is something wrong she did. So can you find the mistake? Can you identify the mistake and then correct it and write down the reason, please? So in your note,
I didn't understand that.
So if you do this work in the loose leaf, I need you to copy both this this is a red box, and copy this red box and the wrong works also. And then right next to it, please draw another box with this check mark, and then correct it here, please, in your note. So what is wrong? Can you think about it? Did he plug -3 into the x properly? Yes, right? And he used parentheses also. Up to here is very good. How about step 2? In the calculator, if you just put it like this, calculator will give you a direct answer. But they want you to figure out step by step. Now you're supposed to use what? PEMDAS, right? So -3, what do? Do you multiply here or third power first? Exponent first. So -3 to the third power is -3 times, -3 times, -3. The other number, negative becomes negative. 3 to the third power is 27. So -27 times 3 is -81. This is good. How about here? Do you multiply this negative? No, you don't do this first, right? Because it's multiplication. You should do what? Exponential first. So -3 squared is 9, positive 9, not negative 9. Negative become positive. So 9 times -2 is -18. Oh, this was wrong, right? And then -6. So you should correct here, like -18. Do you understand? Now, if you go down, you see about 1, 2, 3, 4, 5, and 6, 7, and 9 questions. Okay, by the level. So and then please do it in your note. You don't need to do the all 9 questions. If you look at the handout, if you print it out, or you can see in the, you know, in the pack, was that the file I gave you. If you see it, there is on top, you can see, so I ask you about $30. Each question has different dollars, right? Then make sure when you add them all, it becomes $30. Okay? And that'll be good enough. So if you finish everything, please, you go at the end of the slide, you will see the exit ticket. So also please answer the exit ticket in your note. And then take a pictures of your note, error analysis, and all the solve the problems, and this exit ticket. Take a pictures of them, and can you turn them in the Google Classroom, please, by tonight, 8 p.m. All right, thank you, bye.